In this episode, we're giving our enemies some brains and some style. We'll add smart behavior so they can chase the player, stop at attack range, and use proper animated movement in all directions. Let's build a clean and expandable enemy AI system using state logic and blend it with 2D directional animations just like we did for our player. Let's bring our enemy to life. We're starting with the very first animation, the enemy idle animation. This is the state your enemy will be in when not chasing or attacking, just standing and waiting. With the enemy selected, open the animation window. Click Create and name the animation Torch Enemy Idle Drag. The idle frames from the project window into the animation timeline. Adjust the sample rate if needed for smoothness. In the inspector, make sure loop time is enabled for the animation. This way, the idle animation will play continuously. Now hit play and watch your goblin breathe and twitch with idle menace. That's it for the idle animation. In the next steps, we'll add chasing and attacking animations and connect them in the animator to build our enemy's behavior logic. Let's now write the brain of our enemy, the script that makes it idle by default, and then chase the player when they get close enough. We'll call it Enemy AI Script, and we'll use basic distance checking to control enemy behavior. We'll expose detection range and speed to control how the enemy reacts. Then we grab references to the player, rigid body 2D and animator, plus a movement vector. Inside Start method, we find the player using its tag and grab our rigid body 2D and animator. Make sure your player is tagged as player in the Unity inspector. We measure the distance between the enemy and the player. If the player is within range, the enemy calculates the direction to the player and starts moving. We also update the animator parameters. This is key for making the enemy blend into walk or idle animations smoothly. If the player is too far, the enemy stops and the animation switches to idle. In Fixed Update, we actually apply the movement to the rigid body. This keeps it smooth and physics-friendly. Notice we're using move position instead of setting velocity directly, which is better for top-down games. Now inside Unity, assign the tag player to your player game object and attach this script to your enemy game object. Add rigid body 2D, body type equals kinematic, and a box collider 2D. Right-click in the Animator canvas, Create State from New Blend Tree. Go to the Parameters tab, add 3 new parameters: X input, Y input, and speed. In the inspector, change Blend Type to 2D, Simple Directional. Parameters: X input and Y input. Make sure on the code we are looking for the player tag. Alright, let's test if our enemy AI is actually detecting the player as expected. Now, when the player enters the detection zone, we should see the enemy start chasing. And the directional movement animation should kick in through our blend tree.